Hello. Welcome to Chapter 6, the periodic table. We're going to start by organizing the elements. A little connection to you. How can you organize and classify elements? Well, if you've ever played any kind of card game, you have experience organizing. Because when you're holding the cards in your hand, it's very useful to organize them by colors if you're playing Uno, or by suits if you're playing Go Fish, perhaps by numbers. I don't know any other card games. I think those are the only two. By the end of this lesson, you should be able to answer this question, this guiding question. How did chemists begin to organize the known elements? A few elements, including copper, silver, and gold, have been known for thousands of years. There were only 13 known elements identified by the year 1700. Chemists suspected that even more existed. And then once things started moving along and scientific processes were used to discover new elements, then you saw the rate of discovery increase rapidly. And in fact, one decade, 1766 to 1775, chemists discovered 5 new elements naturally occurring in our world. Early chemists used the properties of elements to sort them into groups. So the properties of elements. Let's look at that. In 1829, a German chemist, J.W. Dobereiner, published a classification system. In his system, the known elements were grouped into triads. Triads, tri means 3. A triad is a set of 3 elements with similar properties. The elements shown here formed one triad. Chlorine, bromine, and iodine may look different, but they have similar chemical properties. Dobereiner noted a pattern in his triads. One element in each triad tended to have properties with values that fell midway between those of the other 2 elements. For example, the average atomic masses of chlorine and iodine is 35.453 plus 126.90 divided by 2, because we're taking the average, or 81.18 AMU. This value is close to the atomic mass of bromine, which is 79.904 atomic mass units. Now, why is it important for scientists to organize elements in a logical way? Finding a logical way to organize the elements made it possible for scientists to determine how many elements they were looking for. Imagine you're searching for something, you're using these proven scientific processes to discover new elements, but you have no idea where to even go. Is there something lighter than hydrogen? Is there something heavier than bromine? Where does gold fit into this? Gold is a soft metal. What in the world is that? So there's no real organization until we start moving here with Mr. Mendeleev.